You are watching channel Math and Methods Academy. In this video we are going to resolve given algebraic fractions into partial fractions. So let's get on with our solution. The first question of this video is three x minus 11 over x plus 3 into x squared plus 1. Now we know that the degree of x in numerator should be lesser than the degree of x in the denominator. So the degree of x in numerator is 1 here, and in the denominator it is 3. How it is 3? When x will be multiplied with x square, the degree will become 3. So it's already a proper algebraic fraction. So we can go ahead with the forming of the partial fractions. Our first factor in this case is linear factor, because maximum power of x in this factor is 1, so it is a linear factor. And the second one, the maximum power is x, so it is quadratic factor. Okay, for linear factor we simply write a constant over linear factor, and when we have a quadratic factor we will be writing two constants, the first one with x and the second one without x. So bx plus c over x squared plus 1. Now we multiply both sides of equation with x plus 3 into x squared plus 1. X plus 3 into x squared plus 1 multiplied by 3x minus 11 over x plus 3 into x squared plus 1 equals to x plus 3 into x squared plus 1 into a over x plus 3 plus bx plus c over x squared plus 1. This will cancel with this and we are left with 3x minus 11. Now we will multiply x plus 3 into x squared plus 1 with both the terms in the bracket, and that way we will get a into x squared plus 1 plus bx plus c into x plus 3 . Let's call this equation as equation number 1. Now we will assume different values of x in order to find the values of constants a, b and c. So first we assume it as minus 3, and we will replace this minus 3 in the equation. A into minus 3 squared plus 1 plus b into minus 3 plus c into minus 3 plus 3. 3 multiplied by minus 3 is minus 9. minus 11 is equal to a into 9 plus 1 plus minus 3b plus c into 0. So we have now left side minus 9 minus 11 will be minus 20 is equal to 10a. We divide both sides by 10. Minus 20 over 10 is equal to 10 over 10a. So our a is equal to minus 2. Now we don't have any value of x that we could place in the equation to find the value of the remaining constants, which are b and c. So in this case what we will do, we will solve this equation and arrange in such a way that we can compare the coefficients of different powers of x on both sides. So let's do that. Our equation is 3x minus 11 is equal to a into x squared plus 1 bx plus c into x plus 3. A into x squared is ax squared plus a plus b x squared plus 3bx plus cx plus 3c. Now we will combine values with the same power of x. So ax squared plus bx squared plus 3bx plus cx plus a plus 3c. In the first two terms we will take x square common, a plus b into x squared, plus in the second two terms x is common, so 3b plus c into x. In the third one, which is without x, it is a plus 3c, and our left side is 0x squared plus 3x minus 1. This 0x squared we have introduced ourselves because there was no term of x squared, so we have written it as 0x squared, which means 0. Now when we compare the coefficients of x squared, which are these ones, we get a plus b is equal to 0. We already have the value of a, which is minus 2. So our b comes out to be 2. And now we compare the coefficients of the terms which are without x, which are these two, minus 11 with this one. So a plus 3c is equal to minus 11. We have the value of a, which is minus 2, plus 3c is equal to minus 11. So 3c is equal to minus 11 plus 2. Three c is equal to minus 9, and we divide both sides by 3, which means c is equal to minus 3. Now we have all the three values of constants a, b and c. So we can write the partial fractions of the given fraction, algebraic fraction. 3x minus 11 over x plus 3 into x squared plus 1 is equal to minus 2 over x plus 3 plus 2x minus 3 over x squared plus 1, which is the answer of this question. Now we move on to our second question of this video, that is 3x plus 7 over x squared plus 1 x plus 3. Again we will check the degrees of x in numerator and denominator and see if the numerator is lesser than the denominator or not. So the numerator, the degree is 1, and denominator, when we multiply this with this we are getting x3, so our denominator degree is 3, which means it is a proper algebraic fraction and we can go ahead with the forming of the partial fractions. Our first factor of the denominator is quadratic factor, and our second one is linear factor. And whenever we have a quadratic factor in the denominator, we will be having two constants in the numerator of that factor, and we will write it like first constant with x, which is ax in this case, plus b over x squared plus 1, and for the linear factor there will be only one constant in the numerator, which is c over x plus 3. Now we multiply both sides by x squared plus 1 into x squared plus 3. Sorry, x plus 3, not x squared plus 3. 3x plus 7 over x squared plus 1 into x plus 3 is equal to x squared plus 1 into x plus 3 into ax plus b over x squared plus 1 plus c over x plus 3. These two will cancel, so we are left with 3x plus 7. Now we will multiply x squared plus 1 into x plus 3 with both the terms which are inside the bracket. By doing so we will be getting ax plus b into x plus 3 plus c into x squared plus 1. This is our equation number 1, we will call it. Now we assume the value of x is equal to minus 3 and we replace it in the, and we substitute it in the equation 1. So 3 into minus 3 plus 7 is equal to a into minus 3 plus b minus 3 plus 3 plus c square of minus 3 plus 1. 3 into minus 3 is minus 9 plus 7 is equal to minus 3a plus b into 0 plus c into 9 plus 1. So minus 2 is equal to 10c, and we divide both sides by 10. Minus 2 over 10 is equal to 10 over 10c. So our value of c is equal to minus 1 over 5. Okay, now we have no value for the x that we can assume in the equation to find the value of the remaining two constants, which are a and b. So in this case we will solve the equation and we will compare the coefficients of x square, x, and the term without x on both sides to form the equation, and then find out the values of a and b with the help of those equations. So we write our equation one more time. 3x plus 7 is equal to ax plus b into x plus 3 plus c into x squared plus 1. Okay, let's multiply. And on the left side we can also write 0x squared, because we don't have any value of x squared, so we have assumed it as 0. Okay, now we multiply ax with x plus 3, so ax squared plus 3ax, then b will be multiplied with x plus 3, so bx plus 3b, cx squared plus c. Now we will combine the values, the terms of x squared, x, and those terms which are without x. We have ax squared, and another term with x squared is cx squared. Then terms with x, which is 3ax plus bx. Now those terms which are without any x, which is 3b plus c. So we take x squared common here, so a plus c into x squared, plus here we take in the second two terms x common, 3a plus b into x, third one which is without x, 3b plus c. Now we will compare the coefficients of x square on both sides, which are this one. So we will get a plus c is equal to 0. We already have the value of c, which is minus 1 over 5. So in this case our a comes out to be plus 1 over 5. And now we compare the coefficients of the terms which are without any x. In that one is my plus 7 with this one 3b plus c. So 3b plus c is equal to 7. We have the value of c, which is minus 1 over 5. So 7. So 3b is equal to 7 plus 1 over 5. 3b is equal to 35 plus 1 over 5. So 3b is equal to 36 over 5. Now we multiply both sides by 1 over 3. So 1 over 3 into 3b is equal to 1 over 3 into 36 over 5. This 3 cancels with 3 and this 3 cancels with 36, and here we get 12. So the value of b is equal to 12 over 5. Now we have got all the values of the three constants a, b and c. So we can write our partial fractions now. So 3x plus 7 over x squared plus 1 into x plus 3 is equal to 1 over 5x plus 12 over 5 over x squared plus 1 plus minus 1 over 5 over x plus 3 . Here we will take LCM, which is 5, so we will get x plus 12 over x squared plus 1, minus will come out here, so we will write 1 over 5 over x plus 3. So finally we will get x plus 12, and 5 will go down, 5 into x squared plus 1. Here also 5 will come down, 5 into x plus 3. So this is our answer of this question. Now our third question of this video. And that third question is 1 over x plus 1 into x squared plus 1. This fraction has no x terms in the numerator, but there are x terms in the denominator, which means the degree of numerator is lesser than the degree of denominator, so it is a proper algebraic fraction. So we can go ahead and form the partial fractions. We have two factors in the denominator. The first one is linear factor. The second one is quadratic factor. In case of linear factor, we will have only one constant in the numerator, so we will write a over x plus 1. And in case of quadratic factor, we will have two constants in the numerator. It will be written as bx plus c. Now we multiply both sides by x plus 1 into x squared plus 1. X plus 1 into x squared plus 1. 1 over x plus 1 to x squared plus 1 is equal to x plus 1 into x squared plus 1, a over x plus 1 plus bx plus c over x squared plus 1. This cancels with this and we are left with only 1 equal to, we multiply x plus 1 into x squared plus 1 with both the terms inside the bracket. By doing this we are getting a into x squared plus 1 plus bx plus c into x plus 1. So we call this equation as equation number 1, and we will assume the value of x as minus 1 here to find out some of the constants which are appearing in this equation. So let x is equal to minus 1. The equation becomes 1 is equal to a into square of minus 1 plus 1 plus b into minus 1 plus c and then minus 1 plus 1. A into 1 plus 1 plus minus b plus c into 0. So 1 is equal to 2a and we divide both sides by 2. 1 over 2 is equal to 2 over 2a. So our a comes out to be 1 over 2. Now we don't have any other value that we can assume and find the value of the remaining constants. So what we will do, we will solve the equation and compare the coefficients of x square, x and the term without x on both sides in order to form equations. Let us write our equation one more time. 1 is equal to a into x squared plus 1 plus bx plus c into x plus 1. Let us solve this. So 1 is equal to ax squared plus a plus bx squared plus bx plus cx plus c. First we multiply this one with these two one by one, and then same thing we did with this one. Okay, now we will group the terms which are with the same power of x. A x squared plus bx squared plus bx plus cx plus c plus a. And instead of 1 we can write 0x squared because there is no x squared here, and 0x because there is no x here, and plus 1, so that we could compare it on other sides of the equation. Here we'll take x squared common, then in the next two terms we take x common, and in the last two there is no x involved in it. Okay, now we will compare the coefficients of x squared on both sides, which are this one, and we get an equation of a plus b is equal to 0. We already have the value of a, which is 1 over 2 plus b is equal to 0. So b comes out to be minus 1 over 2. Now we will compare the coefficient of x on both sides. So we get b plus c is equal to again 0. We have the value of b, which is minus 1 over 2 plus c is equal to 0. So our C comes out to be 1 over 2. Now we have the values of all the three constants, and therefore we can write our partial fractions now. Our fraction is 1 over x plus 1 into x squared plus 1 is equal to 1 over 2 over x plus 1 plus minus 1 over 2 x plus 1 over 2 over x squared plus 1 . Here this 2 will come down. We will take minus common here, so we will be having 1 over 2x minus 1 over 2 over x squared plus 1 minus, we will take LCM here, so we will get x minus 2 over x squared plus 1. So the final answer is 1 over 2 into x plus 1 minus x minus 2 over 2 into x squared plus 1. And this is the answer of this question. Now we move on to our last question of this video. Our last question is 9x minus 7 over x plus 3 into x squared plus 1. It is quite obvious that the degree of x in numerator is lesser than the degree of x in the denominator, so it is a proper algebraic fraction. Now we will analyze its factor in the denominator. The first one is linear factor. The second one is quadratic factor. Now we all know what we do in case of linear factor. We will just write one constant in the numerator and the factor will be in the denominator. And for the quadratic factor, we will have two constants in the numerator. The first one will be with x and the second one will be without. Okay, now we will multiply both sides by x plus 3 into x squared plus 1. X plus 3 into x squared plus 1 into 9x minus 7 over x plus 3 into x squared plus 1 is equal to x plus 3 into x squared plus 1 multiply by a over x plus 3 plus bx plus c over x squared plus 1. Okay, this one will cancel with this one and we are left with 9x minus 7. And now we multiply x plus 3 into x squared plus 1 with both the terms which are there inside the bracket. By doing so, we get a into x squared plus 1 plus bx plus c into x plus 3. Let us call this equation as equation number 1. Now we will assume the value of x as minus 3. Let x is equal to minus 3, and by substituting this value in the equation, we will get 9 into minus 3 minus 7 a into square of minus 3 plus 3b into minus 3 plus c minus 3 plus 3. 9 into minus 3 minus 27, a into 9 plus 1 plus 3 into minus 3b plus c into 0. So we have now minus 34 is equal to a into 10 plus 0 there is no 3 like this here. Okay, so we are getting minus 34 is equal to 10a. We divide both sides by 10, so minus 34 over 10 is equal to 10 over 10a. 10 cancels with 10, this 10 cancels with this one, minus 17 over 5. So the value of a is equal to minus 17 over 5. Now we have no value that we can assume to find the values of the remaining constants b and c. So we will solve the equation and compare their coefficients on both sides to find the equations, to form the equations, and then with the help of those equations we will be finding the values of the remaining two constants. So let's go ahead. We will write the equation one more time. 9x minus 7 is equal to a into x squared plus 1 plus bx plus c into x plus 3 here we are getting ax squared plus a plus bx squared plus 3bx plus cx plus 3c. Now we will gather the terms with the same degree of x. We will write ax squared plus bx squared plus 3bx plus cx plus a plus 3c. Here we will take x common in the first two terms. The next two terms 3b plus x is common, and then the third one which is without x. Left side we can write like 0x squared plus 9x minus 7. We are writing 0 with x squared because there is actually no term with the variable x square. Okay, now we will compare the coefficients of x square on both sides, which will give us a plus b is equal to 0. We already have the value of b, which is 17, which is we already have the value of a with us, which is minus 17 over 5. So we'll be getting our value of b, which is equal to 17 over 5. To find the value of c, we will compare the coefficients of x. Here coefficient of x is 9 and here it is 3b plus c. So it will give us an equation which is 3b plus c is equal to 9. We have the value of b, which is 17 over 5. Seventeen into 3 is 51 over 5 plus c is equal to 9. So c is equal to 9 minus 51 over 5 . 45 minus 51 over 5. So c is equal to minus 6 over 5. Now we have the values of all the three constants, so we can write the partial fractions. Our fraction is 9x minus 7 over x plus 3 into x squared plus 1. A is minus 17 over 5 plus b is 17 over 5 and c is 6 over 5. When we solve it, we'll be getting minus 17 over 5 into x plus 3 plus, here we will take LCM, 5 will come here, so 17x minus 6 over x squared plus 1. When we further simplify it, we'll get minus 17 over 5 into x plus 3 plus 17x minus 6 over 5 into x squared plus 1, and which is the answer of this question. I hope you have understood the concept of forming partial fraction from this video. We discussed here actually two types of factors which are there in the denominator. One is linear factor and the other one is quadratic factor. So that's all for now. Please don't forget to subscribe the channel, and until the next time, take care and bye.